Hello, my name is Ron Gilman. I'm a staff applications engineer here at Atmel Corporation. Today I'm here to talk to you about our new family of LED driver products, the MSL2021 family. These LED drivers are designed for high CRI, or high color rendition index, luminaires. What that means is they will try to maintain a very nice white point once you've set it, regardless of temperature. Typically what happens is if you try to blend two colors of LEDs, the LED will vary with temperature differently. So a white LED will maintain its light output pretty consistently, while a red LED's light output will drop off quite dramatically with temperature. As the LED temperature drops off, for the red-white mixture will vary. So our LED driver products, the MSL2021, MSL2023, and MSL2024 will maintain this color temperature across thermal temperature. These products use the same demo board. The demo board is this board right here. It has an AC line filter on the input side to maintain good EMC and EMI specs. It's followed by a offline converter here, which will convert in a single stage with PFC the AC line voltage to the DC voltage required to drive the main LED white string. In addition, our part will then dynamically control the output voltage of this offline converter. Our LED driver is this little tiny part right here in the center of the board. This right here is the LED load. For this example, the LED load consists of a white string interdigitated with a red string. So as the temperature will vary, we'll notice the different, the maintained white point. In addition to our LED driver, for the main string, we have a floating buck driver to regulate the red string to manage the mismatch in voltages. A red string's VF is often much lower than the VF of the main string. Followed by our LED driver is an Atmel microcontroller that acts as a board controller to control the PWMs coming to the part, as well as providing an interface to a host PC. In addition, on this board, we provide for an explain board interface as well as an RCB interface. I'll now power up this board and go over the standalone operation as well as the operation when it's connected to a PC. So you can bring in your AC line voltage here. This can be a universal input voltage, anywhere from 90 to 100 to 220 volts, 240. So this is the light output of the LEDs. You can use this pot down here to adjust the brightness of the LEDs. In addition to providing a standalone operation, the board also provides for a PC operation of the MSL2021. In order to use the board of the PC, connect a micro USB cable to jumper J7 in the lower right-hand corner here. Once connected, you can launch the PC application software, which is the Atmel LED driver LED demo application shown here. Once started, the LED driver demo will recognize which COM port the board is found on, and once you click connect, it'll connect to the MSL2021 on the board. Once connected, you can adjust the various parameters off the part. You'll start up the software in the Register Access tab, which allows you to see all the various registers on the part. So for example, for this quick demo, I will go ahead and vary the main string's current. So it is set as a default value of 64. I will go ahead and half that current right now. You can either enter it directly by typing it in, or you can toggle one of the bits here to increase or decrease it. Once the bit's toggled, select the check mark, and you can write that value to RAM. So once you write it to RAM, it changes brightness on the board. Additionally, you can change it back again, and you can read what the parameter was in the EEPROM, which will go back to its default value. The device-specific tab goes over the different device-specific methodologies for controlling that color temperature. For the 2021 product, there's a lookup table. So as the temperature varies, the our LED driver will adjust the PWM at different levels depending on the current temperature that's measured on the thermistor on the LED load. So here, if we read the table, you'll notice at the lower temperatures here, we have a smaller scaling factor, and as the temperature increases, as the red LED drops off, we'll increase the temperature at a greater degree to maintain that same white point. The other products in this family is the MSL2023. The MSL2023 is a serial register-based product, so an MCU can directly talk to registers for the two different PWM settings for the main and the red string, or the color adjust string. And in addition is the MSL2024, which we'll demo in a second, which takes two direct PWMs in. So one PWM for the main string and one for the red string. In addition to providing an LED to the PC interface, the additional interfaces on this board is an interface to one of the Atmel Explain boards. So you can take an Atmel Explain board, interface it to this bottom header here, and it will mate directly at the bottom here. And you can use it to do all your development on a board such as this one here. So you can do your code development here and talk to our LED driver and provide a seamless interface. We will now switch to the MSL2024 demo board, which is actually an identical demo board that makes use of the Zigbee Light Link interface here using an RCB board. Here is the MSL2024 demo board. The MSL2024 demo board is exactly identical to a 2021 with a notable difference of the IC on this board is an MSL2024 instead of a 2021. This board now makes use of the RCB interface, which can be used in both ICs. The RCB interface will plug in at this point here. The RCB interface will then communicate back via Zigbee Light Link to an Ethernet gateway board, which is such as this one. This Ethernet gateway board uses a standard Ethernet cable connecting back to a router off screen, and a micro USB to provide power for the board. Once we power up the board, you will notice that the LEDs flash on and flash off. At this point, the board is under the control of Zigbee Light Link, which will be controlled via a standard Android tablet application. The Android application will let you turn off and turn on the LED light. Turn it off and on. In addition, you can set the color saturation level on the top slider here. So if you bring it to the minimum, it'll be a very blue light, or set it to the top and you'll have a very red light. In addition, you can control the brightness with the bottom slider here. So you can set it to a very dim level to a very bright level. So at the very dim level here, in addition to that, you can use the bottom three buttons. Since this only uses two colors, the color wheel is not used for this demo. On the bottom, you have three different scene settings that you can pre-program. The first scene is a bright white, which is a bluish white. And the third and final scene, what we have is a really bright red. And in the middle, you have a really warm, dim white that you can use, that you can also adjust the brightness on in here. This is the Zigbee Light Link interface working with an RCB board and the MSL2024 eval board.